My topic of theory of computation is Turing reaction. Introduction to Turing reaction. Turing reaction is a concept in the theory of computation that involves the study of reactions and interactions in a computational system. It is named after Alan Turing, a pioneer in the field of computer science and the development of a Turing machine. Understanding Turing reaction is crucial for analyzing the behavior and capabilities of computational systems. And here is a picture of how a Turing machine works. A rapidly diffusing inhibitor and slowly diffusing activator. Here is a graph of both time 1 and time 2. The importance of Turing reaction. Turing reaction helps in determining computational complexity of algorithms and problems. It provides insights into the efficiency and performance of computational systems. By studying Turing reaction, researchers can develop more advanced and optimized algorithms. Turing machines and reactions. Turing machines are theoretical models of computation that excuse me, that can simulate various computational processes. In Turing reaction, the focus is on how Turing machines interact with different inputs and produce outputs. The study of Turing reaction helps in analyzing the behavior of Turing machines in different scenarios. And here is an example of a Turing machine where it comes to the Q0, Q1, Q2, Q4, and Q3 and Q4. We have a tape head of X. In all unwritten transition, we go Q rejected. Formal definition of Turing reaction. In the context of the theory of computation, Turing reaction refers to the process of Turing machine transitioning from one state to another based on its current state and input symbol. The reaction of Turing machine is determined by its transition function, which specifies how the machine moves between states. And Turing reaction plays a crucial role in understanding the computational power and limitations of Turing machines. The formal definition of Turing machine is Qx of of t Qx of x LR. The transition function is R B L of delta of Q8. Turing reaction and halting problem. The halting problem is a classic problem in a computer science that involves determining whether a program will halt or run indefinitely. Turing reaction is closely related to the halting problem, and as it involves analyzing the behavior of Turing machines and predicting their outcomes. By studying Turing reactions, researchers can gain insights into the undecidability of halting problem. The halting problem is undecidable, and we can modify H to construct new TM which behaves as very much as H. The computations of H are same as H1, except that H loops indefinitely whenever H terminates at the accepting state. That is, whenever H has on a input W and has otherwise. And here is the M has with input W. Turing reaction and computability. Turing reaction is essential for studying the computability of problems and algorithms. It helps in determining which problems can be solved algorithmically and which ones are undecidable. By analyzing Turing reactions, researchers can establish the boundaries of computability in the theory of computation. Turing reaction and complexity theory. The complexity theory is a branch of computer science that uh, focuses on the study of computational complexity, and the classification of problems is based on their difficulty. Turing reaction plays a major role in a complexity theory by providing a framework for analyzing the computational complexity of algorithms and problems. By understanding Turing reaction, the researchers can classify problems into different complexity classes and analyze their properties. And here is a picture of complexity theory: the computational requirements to recognize languages, model of computation, resources, and hierarchies. The regular language is the type 4, and the context-free languages, the decidable languages, and the all other languages. The applications of Turing reaction. Turing reaction has a various practical applications in a computer science and technology. It is used to design and analysis of algorithms, software systems, and computational models. By applying the principles of Turing reactions, researchers can develop efficiently and optimized solution to complex computational problems. And here is a diagram of a Turing machine diagram. And here is the transition: A tends to R and A tends to L, A tends to B, which is nothing but a read, write, read, move and move right, a read, move left, read and write, move right, like that. Limitations of Turing reaction. While Turing reaction is a powerful concept in the theory of computation, which is using, it has its limitations. The complexity of analyzing Turing reaction increases with the size and the complexity of the computational system. In some cases, the behavior of Turing machines and the reactions may be unpredictable and undeterministic. The future directions in the theory of Turing reaction research, researchers can continue to explore new direction in the study of Turing reaction and its application. By advancing our understand, by future research may focus on developing more advanced computational models that incorporate the principles of Turing reaction. By advancing our understanding of Turing reaction, we can unlock new possibilities in the field of computer science and the computation. Here comes the conclusion. Turing reaction is a fundamental concept in the theory of computation that helps in analyzing and behavior of interaction computational system. By studying Turing reaction, researchers can gain insights into the computational complexities and algorithms and the problems. The study of Turing reactions plays a crucial role in advancing in the field of computer science and technology. This Turing reaction is created by Alan Turing, a pioneer, who is a great scientist, which is a famous in the computer science and technology. By this Turing reaction, we can gain insights into the computational complexity of algorithms, and by this Turing reaction, we can advance the field of computer science and technology. This concept of this concept, which is in the theory of computation, helps in analyzing the behavior and interactions of computational systems. By studying this reaction, Turing reaction, we can find the various insights into the computational and complexity algorithms. Thank you.